question from page 125 from the book of Tom Duckin for O-level physics. Here is question number 1. Describe an experiment to demonstrate the properties of good and bad thermal conductor. Most metals are good thermal conductors. The materials such as wood, glass, cork, plastics and fabrics are thermal insulator or poor conductors. The arrangement of figure 2.32 can be used to show the difference between the brass and wood. Here we have a brass and a wood, and a paper is here. If the rod is passed through a flame, this rod is passed through a flame several times, the paper over the wood scorches. At this side it will scorch, it will burn, but not the paper over the brass. On this side it will not burn. So the reason is that brass conducts the thermal energy away from the paper quickly. So whenever it heats, it take away the heat energy very quickly, so it will not be accumulated on this side. On the other side, preventing the paper from reaching the temperature at which it burns. The wood conducts the thermal energy away only very slowly. So this thermal conductivity is very low, so it not takes away the energy rapidly. So the energy accumulated, so it will give a scorching on this paper on the wood side. So the metal object below body temperature feels colder when an object made up of poor conductors, even if all the objects are at exactly the same temperature, because the metal objects carry thermal energy away faster from the hand. So this is the reason. So thermal conductivity, high thermal conductivity takes away the heat quickly and prevent this paper from burning or scorching. Question number 2. Explain in terms of particles how thermal energy is transferred by conduction in solid. So the conduction and particle model, the two processes occur in a metal. Metals have a large number of free electrons which moves about within the metal. When one part of the metal is heated, the electron that moves faster, their kinetic energy increases and moves further. As a result, they are able to interact with the particles in the cooler parts, so passing on their energy and raising the temperature of these parts. This process occurs quickly. Second process is much slower. The atom or molecule at a hot part makes colder neighboring particles vibrate more vigorously. These atoms and molecular lattice vibrations are less important in metal, but are only way conduction can occur in non-metals, since they do not have a free electron. These non-metals are poor conductor of heat and are good insulator. Explain thermal energy is transferred by convection. Convection is the usual method by which the thermal energy travels through fluids such as liquid and gases. Describe an experiment to illustrate the convection in a liquid. It can be shown in a water by dropping a few crystals of potassium permanganate down a tube to the bottom of the beaker here, or a flask of water. When the tube is removed and the beaker is heated, just below the crystal a small flame, purple streaks of water rises upward and fan outward, rises up and then fan outward. This is because of convection. The stream of water warms moving fluid are called convection current. They arises when a fluid is heated because it expands, becomes less dense and is forced upward by a surrounding cooler, denser fluid which moves under it. So this is convection currents. In question number 4, following statements related to the absorption and emission of radiation. Which of the statements are true and which are false? Energy from the sun reaches the earth by radiation only. True. A dull black surface is a good absorber of radiation. Yes. True. A shiny white surface is a good emitter of radiation. False. Because it does not absorb, it reflects, so it does not emit. So the good absorber is a good emitter. The best radiation heat insulation is provided by vacuum. True. Part 5. Describe the effect of surface color and texture on the emission of radiation. Good and bad emitters. Some surfaces also emits radiation better than others. when they are hot. So hot objects is a better emitter of radiation. If you hold the back of your hand on either side of a hot copper sheet that has one side polished and the other side blackened or rough, it will be found that your hand feels warmer near the dull black surface. Dull black surface, it will feel warmer because dull black surface is a good absorber, so it's better emitter of radiation than the shiny one. The shiny one will be a good reflector, so it does not absorb radiation, so it's not emit the same. The good cooling fins on the heat exchanger of a back of a refrigerator are painted black, so they are good emitters of radiation and they lose heat more quickly. By contrast, saucepans that are polished are poor emitters and keep their heat longer. So poor emitters, so they keep the heat longer. In general, the surfaces that are good absorber of radiation are good emitter when hot. So the good absorber of radiation are the good emitter when they are hot. Reflection of radiation. A dull black surface are better absorber of radiation while than shiny white surfaces, which are instead good reflector of radiation. Reflectors on electric files are made up of polished metal because of its good reflecting properties. Absorption of radiation. Dull black surfaces are better absorber of radiation. Dull black surfaces are better absorber of radiation than white shiny surfaces, which are instead good reflector of radiation. Because describe an experiment to show the properties of good and bad emitter of infrared radiation. So this is the experimental setup. Here we have a back of hand towards the sheet, hot copper sheet with the one side polished and the other side blackened or dull. So the dull side gives warmer and the shiny side gives not much warmer. Describe an experiment to show the properties of good and bad absorber of infrared radiation. The cooling fins on the heat exchanger at the back of a refrigerator are painted black, so are good emitters of radiation and they lose heat more quickly. By contrast, the saucepans that are polished are good emitters and keep their heat longer. In general, the surfaces that are good absorber of radiation are good emitters when hot.